Hi, my topic is the three alternative fusion projects that are making progress. The past few months have proved the nuclear fusion as the ultimate clean and nonpolluting energy source free eternal. One reactor plant project and clustering gigawatt-year net energy of the still on the driving board idea.
This D-News episode is brought to you by Domain.com. We are less than 20 years away from putting the power of the sun on the back of a truck. Just keep Dr. Octo away from it this time, okay? To keep alight, and humans have been working to create fusion for 60 years now. This week, a secret project at Lockheed's Advanced Development Program called Skunkworks believes that they may have solved the riddle and could have a working model for a fusion reactor in 5 years. Most fusion plants involve a tokamak system. I talked about one such reactor plant a year ago. You can check that out. The standard model is a torus chamber lined with powerful electromagnets. Torus is a shape like a donut. Only the traditional designs are in excess of 5,000 tons and as huge as a building. A coalition of countries is actually working on building one in Europe right now, slated to open in 2019. But Lockheed's little beauty is supposedly only 10 by 7 meters. That's like big rig sized. And it's going to be out in less than 20 years. Fusion reactions work by turning those isotopes of hydrogen into superheated plasma of ions and electrons inside of that torus chamber, and they line it again with super powerful electromagnets. The magnets are there to keep that hot plasma from touching the walls, because if the plasma touches, the heat will flow from that plasma into the walls of the torus and cool it down, and it won't work. Once the reactor gets that plasma hot enough, hundreds of millions of degrees hot, the ions will overcome their electrically charged propulsion and smash into each other, fusing and releasing massive amounts of energy with very little radioactive waste. The U.S. Department of Energy says if we can figure this out, the energy in 6 liters of water will be equal to 1 ton of coal.
Another chain used to sign reaction are the field switch smaller scale reactor material used to family heavy hydrogen reaction as
After 1.1 million hours of construction, the fusion reactor Wendelstein 7X is ready to switch on. Over 16 meters across, Wendelstein 7X is the largest example of a type of reactor known as a stellarator. Like the more familiar tokamak reactors, stellarators hold superhot gas in a cage of powerful magnetic fields. Wendelstein 7X has been optimized by a supercomputer to produce the best possible magnetic cage. 50 bizarrely twisted superconducting magnets look more like sculptures than pieces of precision engineering. They are cooled to minus 270 degrees Celsius and operate just a meter away from a gas at 100 million degrees. If Wendelstein 7X can show it holds onto gas as well as a tokamak, then stellarators may step into the limelight.
Decades pass, the Turing and plutonium hydrogen isotopes combination and clean helium neutron on energy realize on possibly alternative dating can enabled by using on the latest supporting and magnetic.
Tri-Alpha Energy, a company in California, has made a big advance in fusion energy. Tri-Alpha's machine is as long as 2 buses. It creates smoke rings of gas and then slams them together at nearly 1,000,000 kilometers per hour. This creates a hollow blob of gas at around 10 million degrees Celsius. In early experiments, the gas fell apart after just a couple of thousandths of a second, but firing beams of high-energy particles helps keep it together. This week, the company announced that using more powerful angled beams keeps the gas tube stable much longer. Next, the team will build a bigger, even more powerful version to reach the enormous temperatures needed for fusion.
Fuel reactor designing was not thought of the family tool shot to my back. Should like the current generation of Jarvis sharpened blast fusion reactors such as NSTX in Princeton, New Jersey, in Milton Park, England, and the project ATER project in France would, unlike the existing, to make this one the smaller and the some more powerful magnets. The magnet's power comes from two second generation reduced superconductor.
Nuclear fusion. In this video, we're going to understand how two or more nucleons merge or fuse together to create something more powerful and meaningful. So let's start by talking about the word nuclear fusion. Nuclear means the process which involves the nucleus, and fusion in English means two or more entities coming together or merging together to form one single entity. So, nuclear fusion can simply be defined as the fusion or combination of nuclei. Scientifically, nuclear fusion can be defined as a nuclear reaction in which lighter nuclei are combined together to form heavier product nuclei with the release of enormous amounts of energy release, which is usually very enormous rather than mass. Therefore, the law of conservation of energy is satisfied. Consider the example of two hydrogen nuclei combining to form deuterium. Here, one hydrogen atom combines with another hydrogen atom, giving deuterium, one positron and one neutrino, as to the heavier helium. But how is this enormous amount of energy being liberated from such a seemingly simple nuclear reaction? To understand this, let's first calculate the loss of mass in the process. The starting mass of the 4 protons is 4 times 1.0078, which is equal to 4.0312 AMU. But the final mass of the helium nucleus is 4.001506 AMU. Therefore, the loss of mass is 4.0312 minus equal to 27.67 mega electron volts.
Made with rare iron copper oxidus ReBCOS, as they decoded, can continue fusion at the higher temperature and the magnetic field is greater than most other superconductors today. For instance, comparative with ITER, where a more robust doubles the magnetic field. Strength for TER peak strength to 30 teslas to the ARC peak magnetic field of the 23 that the.
In its time, Didcot coal-fired power station burned 10,000 tons of fuel a day. What if, in future,
for fusion to happen? And that's really tricky because the plasma's a fluid, it's always moving, and the hot stuff at the center is moving out and you're losing the energy. We really need to keep that trapped.
history is against them? Despite decades of research, no one has got close to fusion power. This giant machine under construction in France was long expected to be first. The received wisdom being that to make fusion work, it has to happen on a grand scale at costs only governments could afford.
So yeah, this is where we hold the plasma, we're just keeping it.
But Tokamak Energy is banking on new advances that mean fusion could be done at a fraction of the scale and cost. Advances like high-temperature superconducting tape to make mega magnets.
This piece of high-temperature superconductor carries the same amount of current as this fat piece of copper.
Good heavens.
So when you wind these round many, many times to make your magnets, you can make much more powerful magnets in small spaces. So these ones allow us to use our more...
The centre of the sun. Until they reach that temperature, they can't achieve fusion. They got a small amount of seed money from the public sector, but since they've attracted nearly £10 million of private investment.
There are plenty of risks in almost all of the companies that we fund, and they continue to be right the way through the development pathway. But this one has probably the most spectacular combination of risk and reward that I've ever seen.
Fusion is coming.
But there's been a major shift towards private money chasing the massive potential of fusion.